This problem says the pressure P of water on a diver's body is a linear function of the diver's depth x. At a depth of 40 feet, the pressure is about 2.168 atmospheres. At a depth of 100 feet, the pressure is about 3.92 atmospheres. Find the formula for P as a function of x. So we're looking for a formula for P as a function of x. And notice in the first sentence, it says the pressure P on a diver's body is a linear function. So we're looking for a linear function where P is the pressure. That's also our output variable, our Y variable. And the depth is the X. It's our input variable. It's our X. And so we know, just from what we've seen here, that we're going to use P for pressure. And we're going to use X for the depth. And we want a linear function, which we know a linear function is in the form of Y equal mx plus b. And so in this case, we're going to use P instead of Y for the pressure. We're going to use X for the depth, but we have to find our slope to plug in for M, and we have to find our Y-intercept to plug in for B. Now, neither one of those is given in the problem, but we can find a slope as long as we have 2 points. And we look at the problem and we notice we do have enough information to create 2 points. And so notice that when we create these points, we're going to have them as ordered pairs where the depth comes first and then the pressure comes second, because our ordered pairs are always X followed by Y, input variable followed by output variable. And in this case, the X is the depth, that's our input variable, and our output variable is the pressure, the P. So creating 2 ordered pairs that are in the form of an ordered pair where depth is first and pressure is second. So the information from the problem, the first set of information we have says at a depth of 40 feet, the pressure is about 2.168 atmospheres. So we can create the ordered pair there where the depth is 40 and the pressure is 2.168. The next sentence says a depth of 100 feet has a pressure of about 3.92 atmospheres. So we can create our second ordered pair using that information. We have a depth of 100 and we have pressure of 3.92. Now we've got our 2 points. We can use those to find our slope. So remember, to find slope, we find change in Y over change in X, or rise over run, or y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Any of those ways work because they all mean the same thing. Basically, we're subtracting the y's to find the change in y, to find the rise. That's what goes on top. So 3.92 minus 2.168. And then same thing to find the change in x or the run. We subtract the x's. So 100 minus 40. Just make sure that you're subtracting the same direction both times. If you do y2 minus y1 on top, you have to do x2 minus x1 on bottom. If you had turned it around, that's fine. You would do 2.168 minus 3.92 on top and 40 minus 100 on the bottom. You get the same slope. So simplifying, subtracting on the top, we get 1.752 over 60 when we subtract on the bottom. And then dividing there gives us 0.0292. So now we know our slope. We need to still find the y-intercept in order to have the formula for the linear function here. And there are a couple of different ways to do that. I'm going to use the point slope formula. The point slope formula allows us to find the equation of the line when we know the slope and we know one point on the line, any point on the line. And so we know the slope and we know 2 points on the line. So we're going to pick one of them. So our point slope formula is y minus y1 is equal to m times x minus x1. We're going to plug in our slope for m. We're going to use one of those points and plug it in for x1 and y1. And then we're going to leave x and y as our variables, because in order to have a function, we have to have an input variable and an output variable. So that's going to be the X and Y here. I'm going to plug in 0.0292 for M, and I'm going to use the second point. Does not matter which one you use. You can use the first one. It will simplify to the exact same equation. I'm choosing to use the second one. Looks like it might be slightly easier to calculate. So plugging in, again, I'm leaving my Y as my output variable, and then I'm subtracting Y1, which is the Y value of the point. And we picked the second point, so 3.92 is the Y value. And that's equal to the slope, which we found to be 0.0292 times, again, I'm leaving X as my input variable, and then I'm subtracting, and for X1, we're using the X value of the point we chose. And so that's the 100. Now we just need to simplify to get it into slope-intercept form, and we'll have the equation of our line. So we first need to distribute, and so Y minus 3.92 is equal to 0.0292 minus, and when we multiply there, we get 2.92. At that point, we just need to get Y by itself, so we're going to add the 3.92 to both sides, and we're going to end up with 0.0292x plus 1. So there's our linear function. The only thing we still need to do now is make sure that we are using the correct variables. Notice it wanted us to use X for the depth, which we are, but it wants us to use P for the pressure. And so instead of using Y for our output variable, we're going to use P. And so P is equal to 0.0292x plus 1 is the linear function for the pressure as a function of the depth. And so entering that, again, we have to make sure we use the variables they want us to use. So we're going to use capital P for pressure is equal to, and then 0.0292, and then times X, which is the depth, and then plus, and then 1.